Hi. Sometimes Git Rebase feels intimidating or confusing. You're not alone. But here's the truth. It's actually very easy. Maybe you only didn't have time to learn it. I explained in this video how it works and how to use it efficiently. By the end, you'll feel confident and in control of your Git workflow. And first point, you should use a graphical user interface Git client. If you are relying solely on the Git CLI, it's time to bring a Git UI into your workflow, and here's why. While the CLI works well for basic flows like add, commit, push, it can get tricky when handling more complex operations like merge and rebase. Also, Git trees can become very complex, and having a visual overview makes understanding and navigating them so much easier. In the end, the result is the same whether you use the CLI or UI client. So there's no need to stress about being ultra efficient with Git comments. Git is just a tool. Focus on what helps you work better. So how does Git actually works? Your Git repository is structured like a data structure. You may think it's a tree at the first glance, but technically it's a graph. The smallest building block in a Git is a commit. A commit represents a snapshot of your code and contains the change between one state of the code and the next. This change is known as diff. Those commits stack together to form the complete history of your project, eventually building it to its current state. Very important, branches in Git are not like traditional branches like you would see on a tree. Instead, they are pointers, labels that reference specific commits within the repository. But what about commits with two parents? How do they work? Those are merge commits. A merge commit occurs when you combine the change from two different commits into one. Essentially, when you merge two commits, Git calculates the difference between both and integrates them into a new commit, preserving the history from both branches. When you perform a merge action in the repository, there is a source commit and a target commit. The target commit is the one that will be preserved. Behind the scenes, a pull request or merge request is essentially just another way to merge commits. The main difference is that PRs/MRs provide a user-friendly interface for requesting reviews and tracking merged changes. But then the most feared enemy appears, a conflict. A conflict occurs when Git tries to merge two commits, but it can't automatically determine how to combine the changes. In this case, you need to manually decide how to resolve the differences and choose the final state. Once you resolve the conflict, the merge is created with the resolution you did. Sometimes people think rebase is similar to merge because they both combine changes, but that's not quite true. While they share the same goal, they go about it in very different ways. Like merge, rebase involves a source branch and a target branch, but the way they work to combine changes is quite different. Here's how rebase works. It takes the commits from source branch up to the point where the branches intersect and create copies of them on top of the target branch. This rewrites the history of the source branch to start from the tip of the target branch, creating a straight linear history. Linear history is what sets rebase apart from merge. While rebase rewrites the history to look like a single continuous line, merge keeps the full history of both branches, preserving their individual commit paths and showing them converging into a single point in the commit graph. If you've tried rebase before, you might wonder why the Git client fails when you attempt to push. As mentioned earlier, rebase creates copies of the commits and places them on top of the target commit. Right after a rebase, you have two versions of your branch: the local rebased branch and the remote original branch. When you try to push, the Git client detects that the histories have diverged. It assumes pushing would overwrite commits on the remote branch, which could result in data loss, so it stops you from proceeding. However, since the rebased commits are copies of the original ones, you won't lose the final code. The changes are still there, just represented as new commits with different hashes. In this situation, you can use a force push to update the remote branch with your rebased history. Important advice: never force push unless you're absolutely sure of what you're doing. Practice first on your own repository to understand the process before attempting it on your team's repository. Thanks for watching until the end. If you have time, please let me know your thoughts or suggestions in the comments below. See you in the next video.